Hey guys, welcome to Inside-out BIM. Today we're going to talk about facades in Dynamo and we're going to try to create Zahner Factory. So yeah, without further ado, let's get on with this. So first of all, I just want to show you the model, actually the script, and what it can do, right? And later on we'll go through the presentation that I've prepared for you. So let's go to Dynamo. So this is the facade that we're going to build today. I'm just going to show you what it can do, right? So we can change the width. As you can see here, I have just some sort of a small values. So because it takes a lot of time to process, so yeah. Let's gonna change the width. As you can see, the width can be changed. The length can be changed of the model. Check out this side, right? The fillet, right? The fillet of this one, of our curve. So you can change the fillet of this one. You can make it bigger, make it smaller. It's up to you. The next thing, you can create you can control the quantity of steel fins. So actually these are the main elements here, and the most complex ones, right? These ones. So you can create the quantity of them, how many of them you would like to have. So you can go 52 or make it again bigger, right? So you can control the quantity of them. Also, you can create the angle of sinus. Actually, I'm going to show you everything thoroughly, but just to show you right now what it can do, right? So it can change the way how that goes, right? So as you can see, as you change values, the angles kind of changing. The angles are changing. So the next thing, you can control the convex. So convex, if I make it bigger, as you can see, that'll make it more pronounced here. Yeah, this is the one that is responsible for this part. So basically how you can make it on the top and the bottom, and how pronounced you want this to be, right? For example, by putting a 3, you can see how that kind of gets bigger. Distance from bottom, of course, it's really important. So we can have, again, small values, but there we go. You can control the distance from bottom, and also you can control the distance from top. So this distance, right? So you can also control this one, and height. So you can control height. As you can see, you can control height of the building. And now we're gonna go to the modifiers for for these fins, for these steel fins, right? So again, here we also have the angle of the sinus, and we have how that affects the quantity of bands. So basically here, as you can see, we have 3 bands, and as you change this, so for example, we can make this, if I go and make this bigger, as you can see, I have 4 bands right now. 1, 2, 3, 4. So this one affects the quantity of bands. The second okay, let's make it back. The next thing is what I call transition. So how smooth your transition will be. Not even how smooth, but just it affects the transition. As you can see, that affects slightly this part. So as I crank this up, that kind of affects the transition. So yeah. The next thing is the convex. So here, convex is, as you can see, this side gets bigger. So once you crank up the value over here, the center part of this element gets bigger. And also you have the scale. So that one is like the total scale of the vertical elements. Like if I go with 3, it will just gonna make all of them bigger, right? So you have a full control over this one. So again, you can control convex for the center one, and also have the thickness of the steel fins. Again, it's really small over here, but you can change this and the thickness will be changed, right? Yeah, now what I want to do is to, and also you can change actually the location of the whole model. For example, if you want to move this on the x-axis, so if you kind of move this on the x, as you can see, that moved to the x-axis. You can move this on the y-axis, right? So it's up to you. Now it's not actually, the point is just optional for people. So what I want to show you is just the presentation and the logic. If you really want to learn something out of this and take a lot out of this, take the most out of this, you need to try to do it yourself. And I'm going to show you a couple of kind of levels. So first of all is going to be the logic. I'm going to show you the logic how you can create this. And what you need to do is to stop the video at this moment and go and try to do it yourself. If you cannot do this, you're going to go to the next level, right? So this is the way that we're going to work. So the logic is like that. So we create 3 points, right? As you can see, we've generated 3 points. One that is determining the width, one that is determining the length. So we've got 3 points, and then we've created a poly curve out of these. And we've created a fillet for this poly curve. So we've generated a poly curve based on 3 points, and then we've just kind of created a fillet for this. And it's really easy when you have like a curve, you can create a surface. So based on the curve that we have, so we've got the poly curve, and we can create a surface out of this. And we can extrude this, right, and say what is the distance should be, and that distance will be the height. The next challenge is to actually create this this shape, right? So as you can see here at this step, what I did, I created that curve, right? And I can use curve pointed parameter node to help us have some points along our curve, right? So along our curve, we have some set amount of points. So you can create curve.pointed parameter and set how many points you would like to have there. So from 0 to 1 and slash and some number, right? And you can have like 10 points, 20 points, 30 points, doesn't matter. So you have the points. Why we're doing this? To get X and Y coordinates, right? So we have these points, and my goal was that I need the points that would follow the curve, and not only this, but I need to change them on the z-axis. So as you can see, I have these points and I have the X and Y coordinates, and here I'm just specifying the z coordinates, and that is the sinus function. We can use the sinus, I hope I pronounced that correctly, but we need to use sinus to actually create that shape. So we have X and Y, so we are taking X and Y out of this one, and for this shape we're creating by using sinus. Then we need to copy this right here, so we need to copy this, and yeah, so we have the bottom and the top part. The next thing is that we need to generate something like this. So as you can see, based on the bottom and the top, and we have these points, right? Based on this information, we need to create these curves, these Nurb curves. This is going to be a challenge, and in the next step I'm going to show you how you can deal with this. So yeah, once you've generated these curves, right, it's pretty easy to finish this one. So you can actually extrude this. So we can extrude these curves, as you can see I've done over here in this picture, and then okay, oops, I need to delete this one. That one it shouldn't be here. Then you have this one, right? You've generated these curves, you extrude them, and then you can actually trim this. So you can trim by using a trim node. You can trim this and you'll get something like this. Right now, I would advise you to stop this video and just try to do it yourself. And if you cannot, you can go back and watch the next section, because the next section is actually about challenges that you may face. So challenges, there are 2 challenges actually. Vertical fins that don't follow, that actual vertical fins that follow the direction of our building. So what do I mean by that? So that is the challenge that we have with these elements. So as you can see, first of all, whenever you build something like Nurb curve, you need to think about how that can be created. And the only answer is by having points, right? So basically, that is the hierarchy that we have. We have points, we have curve, and we have surface, right? So how can we not only have the sinus because that is actually sinus as well, right? As you can see, that shape, that is almost like sinus. We need to do some operation to make it look like I have here. But the point of this, how we can follow the direction of our building, right? So because as you can see we have this curve and we need to follow that direction. So the first challenge, how you can deal with the first challenge is something like that. So you need to just connect bottom and top points that we had, right? So we've generated bottom and top points, and then we can use line by start and end point, right? So this way we can create just curves. The next thing, we can generate points on this curve, right? So that is simple curve pointed parameter and just generate how many you would like them to be. And here actually we cannot see here. I'm going to show you here in Dynamo because you cannot see this one, but this is what I'm showing you there. So or actually let me check out, it's actually line by start point and end point, and these are the vectors. Yeah, so I want to show you the vectors, how you can get the direction of this one. So here let's pretend I'm gonna actually isolate these elements. So I have these lines, right? Let me turn on the preview. So I have these lines, right? The next thing what I did is that I had just the points, just points, actually just vertical points, right? How I can get their direction, right? So what I did over here is that I took the normal of the curve. So we have a cool node that a curve plane at parameter. So basically you set up the curve. So we had, as you can see, for the curve I take our curve, actually this one where I built that curve. So actually, as you can see, it's a little bit of a just the curve that we have. So this curve, right? This curve, it's somewhere over here, should be poly curve. Yeah, this one. So this curve and this set amount of for points I took these ones, I think. Yeah, this amount of points. So it doesn't matter. What matters is that how you can do this. So we take the planes. So if I turn on the preview, this is what you will get. You will get the planes, and then I've generated. You can, if you do this using other method, right? Some other method, it's okay. You can share this method in the comments, right? Maybe it's even better. It's even better, right? So I can implement this in my scripts. So then I took a rectangle, and because we can generate a rectangle based on plane, right? So I have small rectangles. Let me show you. So I took this small rectangles, right? And I created curve pointed parameter. So what I did, right? I have planes. On planes, I've built just some rectangles. They have just some default value for width and length, which equals to 1. And then I've generated curve pointed parameter. So if I show you the preview, why I did this, so we got these points, 1 and 2, right? 2 points. 2 points. I got 2 points. So 0 and 0.25. This is the parameter that we're using. So 2 points. Why I did this? So we can create vector by 2 points. So what we can do is that by having this vector, right, by having this vector, we can actually go and create this geometry translate for our points. So here I have a set amount of, not here, for the geometry here, I think. Yeah, so here I have all of the points, and I'm just moving them on this sinus value on this direction. So if I'm gonna show you the line by start point and direction, right? Just to show you so you can understand why I did this. So let's take any points, right? These points, for example, start point. Let's take this vector. Let's take this vector as my direction. As you can see, what happens, because actually it's a lot of points, I need to build this curve pointed parameter. Okay, somewhere over here that should be. Yeah, I think this one. Yeah. Not this one, maybe this one, start point. Yeah. So this is what we get. This is the direction. So this is how you can visualize your vector. So as you can see where that vector is pointing, right? It's pointing right to the direction that we need. So this way I kind of just move the points, right? So that is another challenge that you may face. So yeah. And the second challenge is when you're working with the let me go back so I can show you. When you need to have points for vertical fins, right? This is exactly what I was talking about. So we have not just the sinus function. So it's not that simple, right? Because if you can see what happens here, that we cannot allow for the value to be 0. So whenever you create a sinus function over here, even if you look at just this shape, as you can see when I'm hovering my mouse, right? So basically this type of shape will not do in our scenario, right? We need to have something different. So first of all, we cannot allow our value for the sinus to be with a negative number, right? So we need to can have negative values, and we need to have some value that will determine the convex. So this is what I'm going to show you here that we've done over here. Here we have, just let's imagine you have some angle and the quantity. So for example, here I've set up that I have a sequence of numbers that have some angle, right? So for example, my angle equals to this one, which is determining actually how many bands I have, and I have the numbers of them, right? So this is the transition. And here I've got some values, right? And the way the sinus works, that we have some minus value, some positive and negative values, because it goes like this, right? It goes like this. And basically you cannot have even a closed loop over here. So what we needed to do is that, what is the logic? That all of these negative numbers, we need to make them be positive, right? So just make them absolute, right? So basically here, this is exactly what I did. So by making them absolute, right? If I go to Dynamo, you can find this if you type math.apps. Oops, not this one. Math.apps, this one, right? Finds the absolute value of a number, right? So basically it will give you only the positive numbers of this ones. So this is what we can do. Let's see, I'm going to show you here in the model. So here we have angles, not this one, just values. Here I have angles, and here I have minus values. If I use math.absolute, I'm going to get only the positive numbers, right? So these, I get only the positive numbers. But what I want to do is to maybe make them more, right? So maybe have this option to make it more pronounced, right? So this is what I did, and this is a cool way. Don't be afraid of using some sort of a scripting, because I think we all should prepare ourselves for like for coding, not just visual coding, but real coding, like in Python and so on, because this is the future, even in architecture. So don't be afraid of something like this. So what I'm doing here is that I'm asking whether my, so I know that my first element equals to 0. So if I have this curve, not all of the, so let me show you so you can understand this. So I can go with the preview, not this one actually, but even like this, okay, it doesn't that matter. So I know where's my first point, right? So if I took the points, right, I can select this ones. So my first point, so if you imagine that I go and I have some curvature like this one will be my first point, right? Like this one will be my first point, and other points shouldn't have lesser value than this one. So yeah, I'm asking whether the A of index of 0, so I'm taking this 0, A of index of 0, and I'm asking whether this 0 is bigger than all of the A's. So let me show you by doing that slower. I'm taking A of 0, right? Let me take this. So I'm gonna get the first value of this, 0. Then I'm asking if it's bigger than just all of the A's, right? And as you can see, it's gonna give me false, 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 true, true, true. and the ones that are bigger with the ones that are, so basically here, the ones that are bigger than A's are actually okay, right? The ones that are here we have false, they are okay, because we're pretty much okay with the fact that they're bigger, but we're not okay with the ones that are smaller, right? For example, with this minus. So I'm asking if that is bigger than A, and if it's true, so if it's bigger than A, that one with the negative number. As you can see where I have true, the 6th one is a true, that one with a negative number. And if that one is with the negative number, I want to create this node, right? Math ABS. So I can type math.abs and put inside of parentheses this variable. Right now it's still not working because we need to actually finish this one. So if it's true, if that 0 is bigger than this value, if it's true, so I want to make something like this. If it's no, just use A. So now I'm just going to show you something like this. You just need to understand the syntax, but it's not complex at all. So for example here, right, we have 0, 0, and when we have positive numbers, that does the same thing. But when we have negative numbers, that one creates actually the ones with positive number. So what we did, again, to reiterate everything, we took the 0 and we asked whether this 0 is bigger than each of this number. And if that, actually, as you can see, a 0 is smaller than this value, right? And that's okay for us. But 0 is bigger than this number, this one with the negative one. And this is the one that we need to change. So if that one is true, I want to apply to this one, math ABS. So I want to make these numbers, I want to convert them to be positive. And here I'm typing if true, and here if false. If you're familiar with Revit, it's not going to be complex for you at all. But here we can also say something, maybe even multiply this by b, by some variable, right? And here you will need to just have some b. I'm just going to type like 4, for example, right? And there we go, we have it. So for example, this is the way how you can do some operations within a code block. It can be quite useful. Leverage this thing, really, it's so powerful. So actually this is the challenges that you may face. Right now we can go to the script. Of course I'm not going to do this from scratch, right, in terms of I'm going to show you each process so you can repeat this, but please try to do it yourself if you really want to take the most out of this. So yeah, let's go to Dynamo and let's explore what we did over here. As I've told you, we've created a points. Here we've created points we created just some points with 0 values, and then we can create coordinate system. It's an optional thing. You can do that without this. I just wanted to make sure that if people need to change the location of this, they're going to be really easy for them, right? They can connect the some other coordinate system, right? So that will be placed in the model right exactly where it needs to be, because we have an amazing node, point by Cartesian coordinates, that creates points based on some coordinate system. You can do this just by this node, point by coordinates. It's really up to you and what your goal is. So what I'm doing, let me kind of orbit this. Let me orbit this a little bit. So I'm going to be showing you something in this way. So I'm creating 3 points, right? Preview. 1 point that is here, and I'm connecting this to the X, and this is my width, right? I'm creating an integer slider. I'm calling that width, and I'm just placing this. The same thing goes for the Y. So I have 2 points, preview. 1 here, and 1 is here. And also I have this origin, right? That is right at, let me turn on the preview. Oh, not freeze, but the preview, okay. Preview. So here we have 1 point, 2nd point, and 3rd point. And I can connect them using code block. Just type something like this, ABS, and just connect this variable. So this one is my A, This is my first point, that is my, not this one. This is my second point, and this is my third point. So something like this. Then we can use polycurve by points. So if I turn on the preview of this, we're going to create something like this. Just a polycurve, right? Then we can apply some fillet. So we can go polycurve.fillet, and we can turn on the preview for this. So we can specify which fillet we want to use. And this one, as you can see, I have it here. So we can change it. And let's wait for a minute so that it can generate values. There we go. So we can change the fillet. The next thing, we're generating points on a curve. So basically we have a curve, which is this one, right? This is that curve, and we can use curve pointed parameter. And we're saying I want to go, because the 0 is the beginning of your curve and the 1 is the end of your curve. So, right, you can say I want to go from 0 to 1 with a set amount of numbers, with a set amount of quantity, right? So, for example, quantity of steel fins, right? So this way we're controlling how many of these points we have along our curve. Once you've done this, actually here out of polycurve you can easily create a surface. So you can use a node that's called curve.extrude, and you can generate just a surface, right? So here we can generate a surface, right? Something like this. And here I've changed the color by using geometry color by geometry color. But it doesn't that matter. So you can actually specify the curve, the direction, and the distance. And the distance will be height. You can also put this into like slider, name this height, and make this building totally parametric. If you remember what I've told you at the very beginning, we generated, what was the whole point of these points, right? What was the whole idea behind this? So we have points. What is really valuable for us is their X and Y location. Because just by having their X and Y location, so we can grab their location by typing this thing in a code block, just A and X. Oops. Okay, I have some lags, but there you go. A.x, and you can kind of extract the values out of axes, out of X, and out of Y values. Why we're doing this? Because we have points, right? We have points, and we want to, oops, and we want to make this curvature. So what we're doing is that we have X and Y. There we go. Actually, now it's kind of a little bit clunky in terms of a messy, but yeah. Now we need to have point by coordinates. As you can see, this is our idea to build this on the bottom preview. So to have these points, and we're connecting X and Y coordinates. So we've generated these points to extract X and Y coordinates. And now we need to get the Z coordinates. How to get them? We're going to create a code block that is going to go from 0 to some specific, to the, as you can see here, we have from 0 with some quantity, so how many of them we want to have, and what step we want to use, right? So this should be over here. So quantity of them and the angle of them, right? So how many? 57. Angle 48, right? So that is the sinus function. Just check out some pictures on the internet. It's going to be really easy for you. So just some angles. So we create a sinus, right? Angles with some quantities, and we create a sinus. And then we multiplying that to make it be more pronounced. If you want to make something be more pronounced, it just simply by multiplying that by some value. Why am I actually kind of adding this number is to move this, because let me show you what I mean by this. So if I just place these points based on this value, right, based on this one, right, for example, let's see where it will end up, right at the bottom, right? So we're getting the maximum value of this, and adding this to these numbers, right? So as you can see here, we added all of these parts to these numbers, so they will be exactly where we need it to be, so we can have some offset, right? Again, try to do it yourself, you will understand this better, because, and the idea, right, if you check out the picture, what we have here is that we definitely here have some offset. Try to do that on your own and you'll definitely understand each concept of this one. So yeah, so basically we're just moving that at some distance, right? So that is the whole idea. So we have a plus b and c. Oh yeah, okay, let me show you again so you can understand this, right? So we can actually see this one, z, see where it is, right? When we're gonna add this, if I'm gonna do and recreate this one, but just without c value, let's go to this one. We're gonna have this at 0. So basically by grabbing the maximum value, we're making that be at the 0, and then we can, oops, I've deleted. But that, so basically by adding this number, we're making that be here at 0, and by adding some c, we can control how the height from the bottom. So if I go here, height distance from bottom, as you can see, we can change it. So yeah, and the same goes for the top. Actually, it's not that complex at all. What we are doing here again, point by coordinates, x and y. We're doing the same thing. We're using math sinus, but here, as you can see, we're taking the sinus of the same numbers, but just with the minus sign. Why we're doing this? Because here, as you can see, we have curvature that goes in this direction, and here curvature goes in this direction. If I were to apply right away just these values, right, it's gonna have like the same ones. Let me show you. As you can see, here and here is the same, but by inputting a minus value, you can make them be different. Like here you have in this direction, here you have in this direction. So that is the whole idea, and follow the same principle. Everything is the same as we did in the bottom one, and the same goes for the top one. Then we have, again, this is the create surface. I'll show you now vertical ones, right? So this is like interesting part, but the most interesting part, but actually I almost showed you everything. So we have bottom and top, right? What we can do with this, we can actually create just vertical elements. So here we've generated vertical elements. Then we create points on these vertical elements, right? Just points with some quantity. You can create this and do this on your own. It's not that big a deal. Then we can calculate the count of these elements. And why we do this actually, because I'm going to show you, it's not for this one, it's a little bit for other part. So actually we have, right, we've generated these points, right? Now we need to think, okay, I need to move these points so they're flat right now. I want to have sinus for them, right? So this type of shape that we have here, like this, right? So this shape, I want to have this shape. So how would I move them? I can use geometry translate, right? So this is the node that we use for moving these points. So this way we can move them, right? But how we can move them? How would we follow the correct direction? And I already showed you that. So here again, we are creating some code block with angle and n to generate math sinus, right? So this is again what I've showed you previously. If you forgot about it, check like maybe a couple of minutes ago, I showed you that. You can go math sinus, and we can actually, I need to delete this one. So we create something like this, right? This is exactly what I showed you, how to deal with this scenario, right? How to actually create these ones. So these are the values that we need to move our points to, right? So here we have x. So here we have just flat points over here, and we need to move them and make something like this. If I go to geometry translate, turn on the preview, and make something like this. How to do this? So we need to have these points that I've created, these distances, right? These distances. Of course, I multiply this, I go with least maximum item, and again the same thing. Try to do it and you'll understand why I did that. I just want to show you the best things. So here what happened is that we have this amount of points, and here the values where we need to move it to are they're just 17, right? So here we have 17 elements, and here we have this amount of elements, 968, 69. And what we need to do is because we want to move each of this one, right? So we're using list of repeated items. So we're taking this amount of items after all of the operations, right? So here, for example, 17 items, and we repeat this amount of time. So we get the count of this list, right? Because now we only have for one element, but here we can get the proper amount of items, right? So we calculate how many lists we have here, and we have 57, and then we can use list of repeated items, right? And there we go, we have list of repeated items, and here we just move them by the vector that I've showed you previously, right? When we have like so check it out, like we have vectors, and we move this by using that vector. Reverse, but I needed to have a reverse one. So we're having like the direction, the geometry is our points, and the distance is the one that we set up over here, right? So we have, our goal was just to have like the same amount of points, right? So here I have these points that are the same, and the values where we need to move it to always also should be the same. And actually from this one it's pretty easy, right? We create Nurbs. So we have points, these points, we have these points. I need to actually click on this one. So we have these points, we generate a Nurb, so we generate a Nurbs, then we extrude this. Let me show you what I do. Then we extrude this on some distance, on some arbitrary distance, like I've picked up the value of 10, it doesn't that matter. So on some distance, right, I've extruded them. So as you can see, I've extruded them. Again, the direction is also by this vector, right? And then I'm going to the geometry trim. How that tool works is that we're picking the geometry that we want to trim. So basically, what is our goal? So we have this, not studs, but these vertical elements. So we have these vertical elements, right? We want to trim them, so I pick them, right? I want to trim them because here I have these surfaces, you can see, right? So I need to trim this over here. So here I need to trim them, right? So get this part. So yeah, I'm using trim, so I'm picking all of these ones, right? So all of these geometries, so all of these ones, and I'm trimming them by this surface. I'm gonna show you by which one. Preview. But what is the caveat here that we've got is that why I didn't use this one. So for example, here this is the one that we've generated, right? But here the height isn't enough for us to trim this, to trim these elements, because if I show you the picture, right, as you can see, they go a little bit above our surface. So I just needed to create something like this. So I go with A, which is my height. I'm adding plus some number, some arbitrary number, and I'm adding B, and my B is my offset from top. So what I'm doing here is just I'm making sure that I'm going above this part. So this surface is above this one, so I can trim this. So that is the condition that you need to actually maintain, right? Right, so here we are trimming this, right? And then we're getting like this structure of the list, and I can flatten this, so to make it like a flattened list, and I can do surface thicken, and I can thicken the surface, and I can create some color for this. So that is the script. I hope that was useful. I think that was a long tutorial, but I hope that was really useful and informative. So yeah, we've done this amazing, and this is an inspiration from Zahner Factory. They're amazing, right? So yeah, that's it for this lesson. I hope that was a useful tutorial in learning about facades in Dynamo. And thank you guys for watching this video up to the very end. And if you're not yet subscribed to this channel, hit the red button down below, and I'll see you very soon in my next video. Yeah, have a nice day.